Hello, I am Indranil Gupta. I am a professor in the Department of Computer Science at IIT Kharagpur. Now, I shall be offering this MOOC course on hardware modeling using Verilog. So, let me tell you a little bit about this course. Verilog is one of the so-called hardware description languages. Well, today there are two very popular competing hardware description languages. One is Verilog, of course, and the other is VHDL. So, what is the basic idea behind these languages? You see, earlier traditionally, whenever we used to design a circuit, the normal procedure was to put all the components on a breadboard or on a soldered Vero board, then test it out whether the circuit is working correctly or not. But nowadays, with the developments in software and the design and synthesis tools that are available with us, the trend has changed altogether. So, today when we design a circuit, design a system, we do not straight away come to the breadboard and start putting in the components and designing the circuit. We specify the circuit in the form of a language. Verilog is one such example. So, once we specify this, we can do two things. Firstly, we can carry out simulation to check whether our specification is actually correct, whether it is meeting whatever was intended. And secondly, there are synthesis tools available. From this Verilog, we can synthesize and generate our final hardware description. Okay? So, that final hardware description may be used in a variety of ways. We can translate our design into, for example, a field programmable gate array or FPGA chip or board, or we can also develop or fabricate an ASIC, application specific integrated circuit. Now, in this course, of course, we shall be discussing the various features of the Verilog language. So, we shall be starting with the basic digital circuit design flow. What is the typical sequence of steps a designer follows in order to design or specify a circuit to start with? So, we shall be looking at the various Verilog language constructs. We shall be seeing through numerous examples how we can create or develop specifications for modeling combinational circuits and also sequential circuits. So, there are a lot of nitty-gritties, lot of tricks and lot of conventions which industries follow in this regard. We shall try to discuss some of these as well. And most importantly, we shall be discussing very specifically about the differences between behavioral specification and structural specification. You see, structural Verilog is a way to create the specification which can be translated into the hardware, which is what most of the designers actually do. But the trouble is that many people who finally does not want to map it into hardware, just he or she is satisfied that whether my design specification is correct or not, he or she may use some Verilog specifications which are said to be non-synthesizable, which means they cannot be translated into the hardware. You see, in terms of the specification, it is fine. You do simulation, just like you write a program in C or Java, you see the output. So, here also you do simulation, you verify that your functionality is correct, but whenever you want to translate it into hardware, you will find that your synthesis tool is giving lot of warning and error messages that you cannot do this, you cannot do that. So, we shall be specifically looking into some details about that. And when we talk about simulation, we have our Verilog specification with us. We need to specify what inputs we need to apply to check the functionality of the circuit. That is what is called writing of test benches. So, we shall see again through many examples how to write test benches in Verilog, and lastly we shall be looking at several case studies starting from very simple ones to more complex ones. So, we intend to design towards the end a complete processor using Verilog. So, that is the overall objective of the course. Now, talking about who all can benefit from this course, well, I should say that of course students will be the primary beneficiaries, because in most undergraduate curriculum in computer science or electronics or electrical engineering, there are courses and laboratories on computer organization and architecture, VLSI design, digital circuit design, and so on. So, in many institutions these courses and labs are supplemented by assignments that require knowledge about hardware description languages like Verilog. So, learning Verilog will be immensely helpful to those students, and also students both in the UG and PG and PhD levels who want to do or create some designs for their research work, for their project work, will also benefit from this course, because now they will know what are the good ways and what are the bad ways of designing. So, what should be done and what should be avoided, so that whatever they design at the end should be reasonably good. And of course, in general, academicians and working professionals who have some interest in design should benefit out of this course. And to make the course interesting, I shall try to discuss as many examples as possible to illustrate the concepts that we shall be discussing throughout the duration of the course. So I again welcome you to this course, and I hope that the journey with me into the details of this course will be a rewarding and interesting experience for you all. Thank you for listening.